Hello, this is Mike at Gamefromscratch, and welcome back to our ongoing LibGDX tutorial series. Today we're going to be taking a look at animation in LibGDX. There are two ways you can animate things, at least out of the box, when it comes to LibGDX. The first one is traditional frame-based animation. That's what we're actually going to be taking a look at today. There's also a bone-based animation option. It's using a third-party product called Spine, but it works a little bit differently. It takes your images and basically transforms them or morphs them based off a skeleton that you provide. That's something I will probably cover separately. It's not built directly into LibGDX. Well, it kind of is and it kind of isn't. It's a purchased product that you have to actually buy. Today what we're actually looking at is frame animation. Frame animation, if you ever did any drawing as a kid, where you, in the top right corner of a book, put frame after frame of a stick man walking or whatever. That is basically frame-based animation. You show a series of images one after the other at a certain time, at a certain frame rate, and it recreates an animation. That's exactly what we're going to look at today. It's quite simple, to be honest, but sometimes a little bit less than intuitive. First off, we're going to start by demonstrating my incredible artistic skills here. And what I'm going to create is just a 4x4 frame, so a 4-frame animation of a stick man walking. So first I need to actually unplug my mouse. Let's go up to new here and create, and I want to create 4 images, 256 apiece, like so. This is the first one, and let's draw there. All right. So save that as, here, let's create a new folder, Stickman. Okay, so there is our first animation, and what I want to do is do another one. Oops, let me copy that guy, new, paste, new, paste, new, oops, paste a little too early there, and paste. Alright, so we got our 4 frames right here as we go. So first guy, let's finish him off, and let's just do paintbrush and all right. Now our next frame, move that one leg in a bit, the other one forward a bit. All right, this is the weirdest walking animation ever. And this one we will put the front leg back a bit, and the other one forward. All right, that's just awful. Other one forward, front one back, so, and put our arms a bit like yay. And for this last guy, we will actually go back to our first frame. All right, so there's your basic steps. Those are your anime. Obviously, you would probably use something better than Stickman to illustrate, but here are your 4 frames of animation of a simple walk cycle. All right, that one looks strangely like that one. It's going to be a very bad animation, but c'est la vie. So now we've got our 4 different images. And what I want to do now is create one sheet to hold them all. So 512 by 512 will hold 256 images, I mean. So let's take the first one, and we'll paste it right there. We'll take the second one, and we will paste it right there. The third one, and we will paste it right there. And finally, our fourth one, and bottom right. All right, there you go. So we got a very basic sprite sheet we created from scratch here. And this is our walking animation. It will loop forever. It's just 4 frames. It's very lousy. Let's go ahead and save this guy. Oh, I screwed this entire thing up. Crap. I don't want a background. All right, this is going to look a little bad. I wanted transparencies. All right, that's a little bit better. So now let's go ahead and save this guy. Call it walkcycle.png. transparencies and everything. All right, so there we have our basic animation that we're going to work with. Let's bring this into our project. I've already gone ahead and created one. All right, here, let me just get out of presentation mode. And we need to copy our file in. So let's grab that out of Stickman, walk cycle, and just drop it in our assets folder, like so. All right, get rid of the logo. So first things, let's go with walk cycle.png instead. Get rid of the ugly red. So that should work. Let's go ahead and create a run configuration here. We've done this 1,000 times, so I'm not even going to bother explaining what I'm doing anymore. And that is desktop, and that runs out of core assets. So, and we want to run the desktop launcher. So now when I run this, we should see our Stickman graphic. There you go. Looks a little weird because of what I did with the transparencies, but there are the 4 frames of our animation. Now what we want to do obviously is just display one of those at a time. So as the character walks, we will update which frame is currently being shown. I'm going to go ahead and I'm going to actually show you 2 ways to do this in this video. The first one is we're going to actually use TextureRegions, which basically is a rectangle within an existing texture. Then the other way we're going to do very quickly, because we covered this in the past, but I'm also going to show you how to use a TextureAtlas, which, if I'm honest, is probably how you are going to go ahead and use this in the future. But first, let's start off with the texture region approach. So let's modify this guy a bit. We still want our sprite batch. We want our texture. So next we need texture region array. Hold our animation frames like so. And we are going to need an animation. The animation is a very handy guy. It's pretty much the heart of this tutorial, so I will show you it a little bit later in a bit more detail. But basically that's the animation controller. That's what handles adding time and flipping from one frame to the next. All right. So we load our texture like normal. I think, yeah. Now that we've got the texture, we go ahead and create our texture. Oh, we're going to create a temporary region of texture. So what we want to do is we want to load all the frames up, but we're going to use this little handy guy that's going to split it out into an array of arrays. And that is, so we create a temporary texture region, 2-dimensional array, like so. We'll call it temp frames, and equals texture region dot split. Now what that does is it takes an image file, like in our case we have a 512 by 512 image, and we're going to say we've got tiles that are 256 by 256, and it's automatically going to take all of those and spit them back to us as a 2-dimensional array. So it kind of makes a grid of texture regions for us from an existing texture. Very handy. So first thing we do is pass in our image, and then, as I said, the dimensions of our individual textures within that image. So this is going to return us a 2x2 grid of frames for our animation. And then what we want to do is actually, and this is going to be somewhat overkill because we've only got 4, but I'm going to loop through them. So, oops, index equals 0. So, your rows, yes, the massive overkill for an array. Columns, like so, and then for each one, we basically want to go ahead and add it to our animation frames. Oh, I actually didn't create that. Oops, I missed something. We also have to allocate our animation frames. So our animation frames equals new texture region array. This is going to actually just be a 2D array though. So what we want to do is the width times the height, or in plain English, 4, like so. All right, so we have to allocate space for all 4 of our frames because we actually don't want to store them in the grid like this. We're actually going to create them in a straight 2D array. So here we're actually just copying them over. So at index ++ equals, and then temp frames at, I think it's J, then I might get that backwards. I might have to come back and revisit this. If my frames seem out of order, this is why. But I think you want to do columns and then rows. But this logic may be reversed. So if your things come out working weird, just swap these two iterators, or these two indexes right here. Oh, 1 second. Sneeze coming on. Perfect. Made the pause button in time. Okay, so that's what we've done. We copied our 2D grid of temporary frames. We took the now instead and made them 1D grid of frames we're going to use. So basically, this is a 4-element array of texture regions within this texture. So no new memory is really being allocated here. It all points back to this original texture. These are just references into the existing texture. So it's kind of like this part starts at 0, 0 and goes to 256, 256. This one starts at 0, 256 and goes to, 512, so etc. So all they really are is the texture region is simply just dimensions within an existing texture. So the real memory is being allocated here. So don't worry over much about this. So what we've done here is we've basically created an array of texture regions that represent our animation. Okay, so now that we've got that guy, let's go back and now use our animation. So I'm at the end of my, yep, okay. So now we need animation equals new animation. All right, and there's a couple things you pass in here. The first one is the frame duration. This is how long you want a frame to last. So if your frame rate, so you've done 30 frames and you want to run it at 30 frames per second, you would set this value to that, or 0. I should know this. This isn't hard math. Or 0.03. One quick word of caution here. You might notice in the past that I always, for my floating point values, post fixed number than f. This is what you're telling the compiler to say. This is a float. So when it's trying to figure out what kind of type it is, this forces it. Now, this is one of those examples where it's perfect why I do it. Because if you come here and I do this, that value is not what you think it is, and your animation will not play because it will turn these into integers, so you will effectively end up with the value of 0. So this is exactly why I do put the F all the time. So there you go. This is saying we want our duration per frame to be 30 times per second, or 30 hertz, or 0.3. In this case, since we've only got 4 frames, we want to say play the entire animation at all 4 frames per second. So we're going to do 1/4 here, or 0.025. So I could also, of course, put in that value there as well, and it's exactly the same. So just something to be aware of. I find this version a bit more legible, to be honest, but whichever one you want to go with it's equally the same thing. Just realize that this first value is the amount of time in fractions of a second for the frame, each individual frame to last. And then next we just pass in our animation frames array, like so. So basically we have just created a new animation using this array of animation frames. Now, to actually use it is super simple. First, we're going to need a new variable. It's just a floating point value called elapsed time. The animation system itself will track how much to move by. It does, so like as you see here, it knows to update at 0.25 seconds per frame, but you do have to pass in how long is elapsed. You have to basically be the clock keeper for the animation class. So to do that, in our render loop, we simply just keep a counter. So elapsed time plus equals gdx.graphics.get delta time. So every frame, the amount is elapsed since the last frame. We simply just keep a running total of this. This will give us the amount of time that's elapsed since the program started. You might want to, if you have pause logic in here, obviously you want to stop incrementing the counter if your game is paused. And then finally, instead of passing in the image like so, we just instead call to our walk animation, our animation, and then there's a couple key values here. The key one we're going to use today is get, oh, sorry, pun wasn't intended, is the get keyframe. And this is going to get basically the next frame that we want, but you have to pass in the amount of time. So like so, and then otherwise it's just like normal. So you pass in the dimensions, etc. So this will return a drawable item based on the current frame in the animation. You can also set if an animation loops or not. We should probably go ahead and do that. So that's actually right here. So when you call get keyframe, you pass in a second value of looping. So all that's saying is after we get to our fourth frame in our animation, for the fifth frame, go back to the first one, and then continue forever. You know what looping is. And that's basically it. So if I've done this correctly, and no promises that I have, we should now have our very crappy Stickman animation. There you go. Alright, that was a really crappy Stickman animation. But that is animation in LibGDX. It's very, very simple. It's just, honestly, as a sequence of images shown back to back. The complexity in this particular example is because we used this texture region approach. We also could have used a TextureAtlas. I'll look at that in a second. By the way, I'm not going to cover it in much detail because I already covered this in the past. The TextureAtlas is covered, I forget the exact name of the tutorial, but flip back through a couple previous ones. There was one on, I think it was called TextureAtlas in Sprite Sheets. Be sure to watch it if you need more information. It covers this in much more detail. But in this case, it also shows how you can just use an image, split the image up into individual cells, and then just use that entire thing as your frames of animation. Now, this guy is a little troublesome on the fact that if my image wasn't a grid of same size, so if it wasn't fit, so I had two 256 images side by side, so obviously I had a 512 image, but if my image source was actually, say, 675 pixels wide with a bunch of white space at the end, this approach simply wouldn't have worked. You would have ended up with garbage results. So this approach doesn't work necessarily as well as the TextureAtlas approach. But that's kind of the extent of it. Now, we'll quickly take a look at that animation class. There's not a whole lot to it. I'm actually surprised there aren't a couple of listeners and such. But what you've got here, you've got a couple key ones. You can see you can return of how long the total animation will take. In theory, this should return 1 second. How long a frame will take, which is our value right here. You can also set that later on. So that again. Play mode is, let me show you the options here. Play mode dot. So how you loop it, or you can play things back in reverse. I don't see a lot of value, or sorry, not value use. I don't know why you would often play an animation in reverse, but your option is there. Ping pong, I think, loops it, but it goes beginning to end, end to beginning to end, end to beginning. Again, I'm not really sure why you would do that. And again, you can loop in reverse. So if you want to change up the values you set here, or the value you set here, you can after the fact, calling individual methods. Otherwise, the only other guy here that's really kind of that useful to you is your animation finished. And this, again, you pass in your elapsed time, and it will tell you if the animation has reached its end, and perhaps you want to queue up. So a lot of times what you probably have is a single character, kind of parent class, that held 7 or 8 or 9 or 10 animations, like walking, jumping, dying, shooting, etc. And it would have all these different animations, and then in your draw method, you would be flipping between whichever animation is active. So you would probably have like an active animation, and then what this would do is probably you would be polling to see, okay, is the current animation done? Because then you want to probably queue up another one after the fact. And this is the extent of what's there. Unfortunately, there is no ability to set a callback for animation ended, although you could probably hack that in. But otherwise, that's literally it. That is animation in LibGDX. Very simple stuff. Very cool that way. Now let's do it again. Let me save this guy out because I'm going to need the source code for GitHub. But that means I need to go and create a new class. Another key part is, since we're going to be using the TextureAtlas, I also need to bring in the tools. So a quick reminder. I'll call this one a TA. That's pretty bad. TextureAtlas animation demo. Game from Scratch. I can't type today. And TextureAtlas animation demo. So, don't care about Android, don't care about iOS, don't care about HTML, but I do care about the tools because that's where our texture maker comes in from. So bring that one in, and I'll go in here, and I want it to create an idea project for me. And let's see, LibGDX, and then we'll put this one in animation 2. All right, so generate. No sense watching this, so I'll see you in a second back in IntelliJ with this loading. Hello and welcome back. So we've created our new project, we've included the tools, etc. So now what I'm going to do is actually create a slightly more realistic sprite sheet. My Stickman wasn't exactly the best example, so I've gone ahead and I've loaded up an existing Blender project here. This is actually created with a product called Mixamo Fuse. If you go through my my tutorials or go back to Gamefromscratch.com, you'll see very, very in-depth preview of how to actually use this guy. So if this looks interesting to you and you want to use it yourself, I have documented it quite well. It's a very cool tool, especially if you have very little animation abilities. So what I'm just going to do is come in here, change my camera out. I want to be each frame at, say, 256 squared. So 256 by 256, and we want to do 100% of that, like so. Frame my camera, side view, so-ish. Play our animation, see if we've got it all. Perfect. Alright, so we stop at frame 120. Set my end accordingly. Now, I don't want 120 frames of animation. That is just going to be way too big. So when I go ahead and render this out, I'm actually going to go to, I'm going to say render every third frame. Like so. And for our output then, let's go ahead and save this right into our projects folder. So, LibGDX, animation 2, core, assets, a new directory, and we'll call this raw sprites. So, all right, so we will save them here. We've set our 256 by 256. The last thing we want to do is turn on transparency, which I always fight to find, but I believe it's in shading. Yeah, so transparent, and then just render those frames. So it's flipping through the 120 frames, rendering every third one. Done. All right. So now we head back to our project over here. And in theory, if I go to the core assets folder, I now have a raw sprites, and there are each frame of animation. So a bit more like what you would see in a real game as opposed to my stickmen. So now what we got to do is we got to take those raw frames and convert them into TextureAtlas for us. So let's go ahead here and create a new directory, and we will call this Sprite Sheet. So, okay, and again, I covered this in another tutorial, so I'm going to run through it very quickly. But now we're going to go use the Texture Packer tool. If you need more information, go back through the earlier video. You will see a lot more instruction on what I'm about to do. Basically, it's in the Tools folder here. I opened the wrong thing. Tools, Texture Packer. And what I'm going to do is make a run configuration for that. So let's see here. I want it to run in the core and assets folder. It runs under the desktop module. It's that folder. And then the last thing we got to do is we have to pass in the source directory and the destination directory. So that was raw sprites, and then it was sprite sheets. And then we'll call, and then the name, my sprite sheet. I believe that's the right parameters. So go ahead and apply and run that. And it is packing that into, all right, it ended up creating 5 sprite sheets because I used a rather large sprite to start with. Each one's going to be 1024 by 1024. Don't worry, the Atlas actually takes care of any of the thought process behind dealing with multiple, though there could be some performance issues on here. So I'm actually using a rather large sprite in this particular example, which is why it resulted in so many sheets. You can pass in parameters that control the output. You could create a single 2048 by 2048 sheet, for example. That's, again, covered in the other tutorial. Go back and see it if you want more. But now if we come back here to our assets, you'll see I have a single .atlas, and then it's created me 5 PNG files of all of my animations, like so. Okay, so now that we have this this atlas and these things created, let's go ahead and now create our code to do animation. The end process is very, very similar to what we were working with before. I just got to remember assets, sprite sheets, my sprite sheet atlas. Totally going to forget that. All right, so let's switch into presentation mode. Sorry if I forgot to do that earlier. I'm not sure if I did or not. So now we need to do basically the same thing. We need a private text. Yeah, I can't type. Atlas. We'll call this that. We need a animation. We've been down this road. I'm going to bring in the right one. Like that. We need... So why am I doing private this time? I didn't before. No particular reason. I just kind of forgot last time, to be honest. You should probably scope your variables. It doesn't really make a difference because this isn't a very elaborate class. But I'm being a little bit more proper today. So now we got to go ahead and load in our TextureAtlas. So TextureAtlas equals new TextureAtlas. And it's gdx.files.internal. And it was... I told you I'd forget. All right. Shop. So that is sprite sheets. My sprite sheet dot. Oops. Atlas. Like so. Yeah. Okay. So load our TextureAtlas in. Once again, Atlas is like a kind of a table of contents to different images within image file. As you saw, it made 5 of them, different locations within each of those. Lets us treat them as a one giant whole. Again, grouping all of your images together into a single image is a very good performance item. And we create our image. Exact same logic as before. Let's do our frame rate as... We got a lot more frames of animation, so we'll do 30 frames of 30 updates per second of animation, and then we just pass in our TextureAtlas, and we're going to get all of them, like pass it in as an entirety, let animation do its thing. You can actually have passed in, say the first 6 frames were a walk animation, and then the next 5 frames were a jump animation, etc. You can actually pass that in and you create this way, but we're going to use the entire atlas as our animation because it's just one singular walk sprite sheet. By the way, technically, TextureAtlas should be disposed of. Here, I'll be good for once. And implement dispose, and we want to, let's say it'd be the batch needs to be disposed. Batch needs to be dipped. Disposed and TextureAtlas disposed. I know I don't do that half the time. I do half the time. I leave it to you as an exercise to the viewer to figure out when you should be calling dispose or not. Basically, if it's got a dispose method, you should call it. Small examples. We're not really leaking memory, but best practices. You should get in the habit. All right, let's get rid of this god-awful red clear color. And then our batch simply... Oh, no, we need to update our elapsed time. Same logic as before. Elapsed time plus equals gdx.graphics.get delta. So, and finally, batch.draw, and then TextureAtlas.get, oops, nope, animation, my bad. Same logic, animation.get keyframe, elapsed time, looping, true, and then once again we'll just draw it at the origin like so. And in theory that's it. So let's go up here, create a run configuration. So we've only got one for our texture packer, so we need one for our application. So application, run desktop. And it is the desktop we are running is our core assets directory that we run from, and desktop launcher is our main. All right. So in theory, big theory, there's a lot of code written there, but this should, there you go. So that is animation in LibGDX. It's very, 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 very simple to do, and the results come out pretty solid looking. Now, as you can see, he's going a little fast. So let's say we want to slow that down a bit. So instead, let's do that by about half the speed. So 15 updates per second. Go ahead and run that, and that looks a little bit more realistic. That's it. That is how you animate in LibGDX. A very, very powerful system, but very, very simple. It's just like you show an image after an image after an image after an image after an image, and all those images combined go together to make your animation. You probably, real world situation, you would have multiple animations. Then you start getting into a little weird situations like I need to move from a walk to a jump, and I'm midway through the walk cycle. How do I blend this into a jump? And that's either something your artist solves, or you bring yourself to a complete walk, like to your end of your walk cycle before the jump, which often isn't acceptable. Or this is where bone skeletal animation actually comes in very handy, because then you can do something called a blend in between two sets of keyframes. Different topic for a different day. Probably cover that at a later point. But if you're dealing with it with this pure sprite drawing thing, what you often would want to do is create a couple of transitory sprite animations, so something that is somewhere in between the walk and the jump, so you can use that as your transition. Or you could actually write some code that would actually do a bit of a takes the final animation, the first animation, the second animation, and does a blend between them. But getting that to not look like crap is probably going to be a bit of a challenge. But simple animation, super easy. Like literally, it's just like this. You could have multiple animations, as many as you need. So what we'd often do is create like a character class to hold all this stuff, and then switch between what the current active animation is in that update or draw function. But that's it. I hope you enjoyed that. Thank you very much.